myth today is, do heavier objects fall faster than lighter objects?
And see, here's the thing. People believe this because the constant pull of gravity, if it's taken out of the equation, it would make sense for the heavier objects to fall faster than light objects. Like if I threw Zach off a roof, he would probably fall faster than I would.
For our experiment, we drew off two different weights, one that weighed 11.33 kilograms and the other that weighed 2.67 kilograms. And we wanted to see which one, if any of them, hit the ground first.
Ah! Kind of like this.
3, 2, 1, go! Alright, 3, 2, 1, go.
In conclusion, due to the fact that the acceleration due to gravity, negative 9.8 meters per second squared, is a constant for every object, objects without air resistance will fall to Earth at the same time, as you saw in our videos. So, our second myth is, do bullets spark when striking metal, kind of like when you see in the movies?
Why do people believe this? Well, we can thank Hollywood for that. So many movies for special effects show bullets sparking off metal or going through metal and sparking, such as this clip.
However, this is what actually occurs.
Why don't bullets spark? Many bullets are made of lead surrounded by a copper coating, which means the copper is really conductive, but it's incredibly hard to make spark when it hits objects.
In a .45 caliber handgun, the friction caused by heat and resulting in energy of the bullet leaving the barrel lasts only 1/1000th of a second. In a standard Remington .45 caliber bullet, with the mass equaling about 15 grams and the velocity on average 267 meters per second, the energy of the bullet in the barrel, using the standard kinetic energy equation, is about 530 joules. At the same time, the energy of the bullet needed for a target spark is also 530 joules. So logically, once the bullet hits the air, it's going to cool down and the energy is going to drop. This explains why you see a spark at the beginning,
But not at the end.
as soon as the bullet leaves the muzzle, it experiences air resistance, and so this decreases the temperature caused by the friction of the bullet going through the barrel, in turn decreasing the energy level, thus leaving it as an inadequate amount of energy to cause a spark once it strikes the actual object.
In conclusion, due to air resistance decreasing both the energy and temperature of the standard copper-coated bullet, a bullet that strikes any metal object will not spark upon impact.